I'm going to do a quick walkthrough of lesson 7 with you today. If you haven't done lesson 6 yet, it's really important that you go back and do that first. I'm going to mention a few things today which has to do with lesson 6. So if you haven't done that yet, I would recommend going back just so that you have a bit more information and you sort of know how to do the calculations. So yesterday we talked about bending of light, which we called refraction. And hopefully what you noticed by doing that little activity online was that depending what the substance is, it's going to bend the light slightly differently. So we did an example with air, glass, and water, and each of those things was going to bend the light in a slightly different way. So yesterday's lesson, we basically used this formula, which is n equals sine I over sine R. And as I was saying, this one here, this is a lesson 6 concept. So I did a video yesterday which was showing you how to actually calculate that. So if you need to, you can go back to that video and just check it out again. Today's lesson, we're actually going to focus on something different, which I mentioned right here, index of refraction. So what we're doing is actually quantifying it. And I mentioned there that air is the least optically dense. And what that means is that we assume that the light can move pretty quickly through air. As we start changing that to, let's say, glass or water like yesterday, we see that it starts to slow down the light. So we use this quantity called index of refraction to describe that. So in yesterday's lesson, I know you saw this guy, which is n equals sine I over sine R. And so those are when I would have an angle of incidence and angle of refraction. Sometimes we don't have that information. Instead, we might have information about the speed. So yesterday we had no information about speed, but today we're going to start to have that information. So on the side here, I have this little triangle. And if you've ever used this before, this triangle is just a way to remember sort of how to do calculations. So just really briefly how it works, and I'll just outline first like what these symbols are. We have n, which I mentioned previously. This is index of refraction. Right. C is the speed of light in a vacuum. And a vacuum is not the vacuums that we have at home to like clean up our house. A vacuum is essentially a space where there are absolutely no other particles. So in real life, we know that air does have particles, but this is sort of like the closest value we have for air. So for air, we always assume and also for a vacuum, like I was saying before, if we were in space or if we had some man-made version of that, it's always going to be the exact same speed. It's what we call a standard. So just scrolling down a little bit here, this value 3.00 times 10 to the power of 8 meters per second, which actually is, if we extend that out and we make that into a standard number, is 300 million meters per second. So light moves extremely quickly as it's moving through air. And then I mentioned right here, value of C is always that number. So this is a constant, right? This does not change. So this number, we always know this number, okay? I had mentioned in the weekly schedule, there's a little sheet called the optics reference sheet, and one of the numbers on there is C. Now, what does change depending on which type of medium you have, which type of substance, are going to be your N and your V. So the table that I've popped in over here is the index of refraction for different medium. So if I'm looking at air or a vacuum, it's going to be 1. If I'm looking at anything else, it's going to change the number. And essentially what the reason for this is that the speed is going to change. Okay, so I'm going to just add in here speed of light changes. And we saw that yesterday. We did the example yesterday of water or glass, and we saw that as the light ray moves from air into those different things, it changes the speed. Okay, so that V and that N, we are going to have to calculate things. So I've put a little bit of practice on the second page for you guys, just playing around with scientific notation a little bit. It's something you learn in like elementary school, but we kind of forget about it a little bit. So we are going to do some practice of that. I've just put a few examples down here. And I want to just mention, I'm not going to go through all of the examples, but I want to just mention use of the GRASS method. So it's just a little acronym. You might have seen it in math or in science last year. GRASS is essentially just the steps that we take when we're approaching a math style question. So I've mentioned it over here. G is that we list out what's given to us in the question. As I mentioned, the C is always the same number, so that's always a given. What might change, and in this case, we've been given speed of light in a sample of glass. So that would be V equals to whatever that number is. So here I'm just listing out the givens. What's required of me is often listed at the end of the question. So in this question, it says, what is the refractive index? Refractive index is the same thing as index of refraction. So that's the same thing as N. Okay, so between these three quantities now, I need to use the formula. So I'm going to scroll back up just for a second and just explain the use of this triangle. Now, some people don't like to use the triangle. They prefer to just memorize the equation. I'm fine with either. So what I'll just mention here is if we're trying to solve for n, what we're left with is c over v. So as in c divided by v. Okay, so in my analysis or my A, I'm listing simply that formula. So again, I will never be asked to necessarily solve for C because that's a constant. We always know it. But we're going to see in other questions, like in example 2, you could be asked to solve for V. Okay. Now I want to just mention something quickly in my solution. So I've written out N equals C over V in analysis. So that's good. And then in solution, I'm just putting the numbers in. So just like math, where you would just put in the variables for those. So C being 3.00 times 10 to the 8, and V being 1.91 times 10 to the power of 8. Now, what I'm doing right here with crossing out these units, I'm going to just explain it on the side. If you have the same units on the top and the bottom of the equation, a top and the bottom of the fraction, these units cancel out because we're essentially dividing them. So what I mean by that is that when I'm doing these calculations, meters per second cancels out meters per second, okay? Thinking about that in a math way, if I had x over x, those would just cancel out because they just equal to 1. So we're going to get some practice with doing that. The reason I'm bringing it up is that the final n answer that I have over here, it is unitless, okay? N has no units. And when you guys get down to working on the textbook questions, there's a question about that. You're going to have to read about it in the textbook as well. But essentially, why it has no units is that it's a ratio that these two values end up canceling out. So you've just ended up, excuse me, with no units. I'm going to scroll back up for just a quick sec, which is to look at this table. So I mentioned here there are no units. So index of refraction, it's not a speed, right? So speeds would be like kilometers per hour or meters per second or so forth. Index of refraction is a ratio, so it's two numbers divided by each other. We would not have any units for that. I mentioned down here also, this is specific to a substance. It's a unique property. So just like in grade 9 science, you learned that density is a unique property of a certain thing. We can also describe index of refraction as something unique. It's special to that particular medium or that particular substance. So I'm just going to briefly go back down here for a sec, which is example 2. So this time we're being asked what is the speed of light in water, given that water has an index of refraction of 1.33. Now, on first glance, this might seem like, oh, they've only given us one value. But remember, we always know C. Okay, C is a constant, so it never changes. We can always write it in. As I said before, we're looking through that question and seeing what variable do they want us to solve. And they've said, what is the speed of light in water? So we know that that is v. So I've put for required v equals question mark. And part of why we're doing this in so many steps is sometimes you can get lost in the steps and make an error or make a mistake. So if that happens, you just want to be sure to write your steps out and you can get sort of part marks. So just like you would do in math or anything like that. Now here I have also my equation. Now I've already manipulated the equation, so I'm going to show you how I got this by going back up to my diagram up here. And I'm just going to quickly, oops. I just want to quickly erase this for a sec. So this time, what my goal is to find is actually V. So I want V equals to something. And so V is going to equal C over N. So that's essentially how we use this table, is that we decide what we're solving for, and then we create the fraction from what's left over. So just scrolling back down to example number 2, that's my equation I'm going to use. Now over here, I'm actually going to show you using my calculator. So I'm going to pull it up for you. I have 3.00 times 10 to the 8. That was C. That's the standard value we know. And then 1.33. Okay. Now I want to notice quickly, we have a meters per second on the top, but not on the bottom. So at the end, we should be still left with meters per second, which is makes sense because we're talking about a speed. So I'm going to pull up for you guys my calculator. This one here, it doesn't actually matter if you're using scientific or not. Mine is just set to scientific because that's what I was using yesterday, but if it's not, it doesn't really matter. So I'm going to show you on my calculator how I would type this in. So I have 3 times 10 to the power of 8. So on my calculator, it looks like this. Okay. And when I press equal, it's going to equal out to this big, huge number. And that is totally fine. Okay. Some calculators are set to do that. So that's my number up at the top. Now, I'm sure that in math somewhere else you've used those buttons before. So yours is going to look slightly different from mine. But every time it should be a giant number for the speed because just remembering light moves really, really fast. So you should have like a massive, huge number. Then I'm going to divide it by 1.33 because that was my index of refraction. Now, what I get at the end is this big, huge number, 225 million, with all these other things beside it. So what I've done over here is I've changed this number into scientific notation. And I'm just going to give you guys like a really brief instruction about that. What it is that I've done, and I can do this in my head, is I've just taken the decimal point and I've counted how many spaces do I want to move it over so that I have 2 point something. So here I would move it over 1, 2, 3, 4, 5, 6, 7, 8 times. And so when I rewrite this, I should always leave my answer, if possible, in scientific notation. Okay, because no one wants to read a huge, massive number that's like 225 million. Okay. Then the last one is just the statement. Again, I have my units here. I was left over with units up at the top. They didn't cancel out. So on the next page, it's just a bit of practice for you guys. I filled in a couple of them, which are practicing with scientific notation. So here I've sort of shown it already. I'm counting how many spaces back I need to move the decimal place. So if I'm moving it to the left this way, I'm going to have a positive number. Okay, so in this case, it's positive 3. Down here, I'm moving the decimal place in the opposite direction. So I'm moving it by 5 spaces to make it 2.3 times 10 to the 5. Doing it the opposite way, on this side, I have 2.30 times 10 to the 4. So you can use your calculator for this, but it's pretty simple actually just to think about it, is how many spaces I would move the decimal place. So I would end up with 230, right? 1, 2, and then I would have 2 more zeros there, like this. And if I wanted to double check that, I totally could. I would just check it by going into my calculator and typing that in. Okay. So I'm going to leave this with you guys to do some practice with. I'll just make a really quick note here. The answers for this are on the handout, starting on page 4. I think it's page 4 to 6 or something like that. So you guys can check it out there. There's a whole bunch of practice questions below. Same thing, that's found in the handout. Down here, same thing. These answers are all in the handout. You'll notice, and I don't have it pulled up on this PDF, there are additional questions for practice on the 3rd page. Those are totally optional. You are not going to get any tested at all on that. So those are just if you feel confident and you feel like doing them, go ahead, but there's not going to be any sort of assessment on that. So I hope this video helps you guys to work through some of the questions. I'm going to press stop on here and just upload it for you. So if you have more questions, just let us know.